as you saw in that video, we have a double cone where we are cutting through the cross sections for the, you don't have to draw this, we're cutting through the cone for the different cross sections. So we have 4 different conic sections. Okay, we have a circle, an ellipse, a parabola, and a hyperbola. Okay, we're going to take, now you've already learned how to graph circles. We're not going to take a day for circles, but we're going to take 1 day for each ellipse, hyperbola, and parabola to learn how to graph them and the different geometric properties that they have. Okay, so our definition here, because you guys are kind of like freaking out about what is a conic section, whether you write this down or not is up to you, but the formal definition of a conic section is a shape formed when a plane intersects a double-naped cone and does not pass through the vertex. So we have circle, ellipse, parabola, and hyperbola. And as you see down here, algebraically, and depending on the type of conic will depend on how that algebraic form looks. But we could have an x squared, we could have a y squared, we could have an xy term, we could have an x term, a y term, and a constant. Okay? Now, I'm not going to throw this at you all at once. We're going to take this little by little. Okay? We are not going to see any equation with the xy term until next week, because that's what makes a rotated conic. Okay? And we're not going to rotate conics from what conics are. Okay? So what you'll see this week are equations with x squared and or y squared, and then potentially an x or a y, definitely a constant of some kind. Okay? I would not take the time to draw those pictures. They're in your book if you want to see them. Now notice how the definition of a conic section is that this plane intersects the double cone, not through the vertex, right? If we were to intersect this double cone in the vertex, we're not going to actually look at these examples, but let's just think about what it would look like. We could intersect at a point. We could intersect at that line down the diagonal, or we can intersect so that we're going through the 2 lines together. We're not going to worry about those. We're just going to worry about the actual conic sections. Okay? These are the ones that we are going to graph together. Okay? Now, don't write this down. Well, actually, write down the circle and its equation, okay? So each conic is going to be defined as a set of points satisfying a geometric property, okay? The example of a circle is the set of points that all have the same distance from a fixed point, okay? We think of that as our radius, right? And that fixed point is the center. But notice how it is described geometrically, and then we're given an equation. We're going to do that for each conic section. Okay? There is some geometric property about all of the points on our graph that is special. And so we're going to talk about that for each one of them. For a circle, all of the points on a circle are equidistant from a fixed point. So they're all 1 radius away from the center is what that's saying. Okay, and whether you remember from this from geometry and algebra 2, and we've talked about it here and there in pre-calc, but x minus h squared plus y minus k squared equals r squared, where r is the radius and hk is our center. Get used to those letters h and k. They're going to be involved in every single conic that we have. So let's talk about a parabola. You've graphed parabolas before, but not like what we're going to do today. Okay? First of all, we can have vertical parabolas and we can have horizontal parabolas. So we're going to graph parabolas that open up or down and some that open left or right. Okay? And we're going to graph them based on their geometric property, not based on plugging in points to get 0, 0, 1, 1, 2, 4. Okay, we're going to graph based on their geometric property. So before you start writing this down, just look at it with me as I describe it. So a parabola is the set of points in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus that's not on the line. Ugh. Okay, so you're going to write this down. Just hold on. What this is saying is that every coordinate on the parabola has the same distance from focus as it does to directrix. This coordinate has the same distance from the focus to the directrix. This coordinate has the same distance from the focus to the directrix. Over and over and over again. Go ahead and write down and draw what you would like to. So we've seen a parabola and we've seen an axis of symmetry. We've seen a vertex. Focus, that's new. Directrix, that is new. Also, I have a pink calculator plugged in over here on the wall, if that's anybody's from the test. It's either this class or 5th hour. When you're done writing it down, we'll talk through the definition one more time. So when we graph a parabola, we need to figure out where the vertex is, and that's nothing new. We've always needed to know where the vertex is, okay? But what is new is that we have this point called the focus that lies inside of our parabola, and we have this line that is perpendicular to the axis of symmetry that lies outside our parabola, okay? And every single point that we pick out on the parabola has the same distance from the focus as it does to the directrix. Every point is the same distance to the focus as it is to the directrix. Okay? So no matter what point we pick along this red parabola, if we measure the distance to the focus, it'll be the same as when we measure the distance to the directrix. Okay? So what I'm going to ask you to do is you are going to graph for me the parabola with the focus inside and the directrix. I'm not going to ask you to graph the axis of symmetry, but you know it's there. What I'm going to be worried about is the shape of the parabola. So you're going to have to graph more than one point, and I'll show you how to do that. And I need the focus and I need the directrix. Okay. So I am going to go through the standard form for each. Okay. Over here, when I gave you this example of what a conic is, this is what we call general form. Okay. It's just in general. All right. But standard form is a way where we can tell where the vertex is and where the focus is and all of that. So we're going to write down two different standard forms, one for each type of parabola. So let's go ahead and talk about a parabola that opens vertically. Go ahead and write these down for me. So that P is the distance that our vertex is from the directrix and the focus. Okay, that's how we're going to figure out where to plot each of those. Okay, and I have these written up here like this for you, but this isn't really how I want you to remember them. I want you to remember them as being P away from the vertex. I guess I should write. I want you to remember the property, not the formula, okay? Okay, so that value P is going to tell you how far the directrix is from the focus, the vertex, and how far the focus is from the directrix. We know the focus needs to go inside. We know the directrix needs to go outside. So I don't want you to have to remember the K minus P or the K plus P. Ugh. I just want you to use it on your graph, and I'll show you what I mean by that, okay? What I really need you to be able to memorize is this right here, okay? Couple things I want you to notice about this. When we did parabolas, I guess over the past like 3 years, it was always like y equals x squared, blah, 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 right? We always solved for y, and the coefficient was always with the x squared. Is the coefficient with the x squared? No, if we have any sort of coefficient, it's over here attached to the y minus k. Okay, so that's going to be a little different than what we're used to. Okay, so when we graph, what I'm going to have you do, and I don't want you to draw this, I don't think it's necessary. I'm going to have you plot the vertex, and then I'm going to have you count P to plot your focus, and then I'm going to have you count P the other way to draw your directrix, and then I'll show you how to get a couple points on the parabola. Okay. Now, if we have a a horizontal parabola, what do you think is going to change about this standard form? The squared is going to go on the other side, which also means the coefficient would need to go on the other side. Okay, so if our parabola is going to open right or left, now we have y squared and x is a linear variable. So there's going to be a few things that you're going to need to be able to determine about your parabola. Okay, you need to know if it's going to open vertical or horizontal. Okay, and we're going to know that based on whichever variable is squared. If x is squared, that's normal to us. It's going to open up or down. If the y squared, that's kind of awkward to us. Our parabola is going to open left or right. Will you remind me, how do I know the difference between a parabola opening up versus a parabola opening down? How did we know it was opening down instead of up? There was a negative coefficient, okay? So if P is negative, if that 4P is negative, we're going to be opening in the opposite direction, okay? Over here on the vertical, if 4P is negative, we're going to have a parabola opening down. Over here with the horizontal, if 4P is negative, we're going to be opening left. Right would be the positive, left would be the negative, okay? Because that's the direction the axis would face. Okay, so we're going to go through 3 examples. We're going to start off very simple, okay? And then we're going to kind of work our way to more complicated examples, okay? So my goal is to get through 3 of them. Let's start with this one. y squared equals 8x. Okay, so first of all, is this in standard form? Okay.
It doesn't look like it.
It doesn't look like it because we don't have like the minus h and the minus k.
What about the p? Is the p the x?
The 4p is the 8. Okay, so let's come back over to here. We need a y minus k squared equals a 4p times x minus h. So since y is squared, we know the coefficient needs to be with the linear variable, which is opposite from what we used to do. But here I have a squared term. The coefficient is with the linear term. So we're actually good. The reason it looks so awkward is because we don't have like that y minus k or x minus h. Because our vertex is going to be where? If there's no h or k, what does that mean h and k equal? Okay. So our vertex is going to be at 0. Now 8 is in place of that 4p. Okay? So if we let 8 equal 4p, what does p equal?
2.
P equals 2. Okay? So we know that this is going to be opening horizontally. And since P, or 4P, however you would like to view it, since P is positive, we know that we need to be opening to the right. Okay? So I don't want you to look at that plus P minus P business that I had you write down. That was there more for reference. This is what I want you to think about. I want you to plot your vertex 0, 0. Okay? If this is going to open to the right, and we want our focus to be inside of our parabola, P is 2, so I am going to move 1, 2 units inside of my parabola for our focus. So now I can determine from my graph that the focus is at 2, 0. Also, I know that the directrix is 2 units outside of my parabola. So from the vertex, I'm going to count P units away, so 2 since P is 2. And I am going to draw a line that is perpendicular to the axis of symmetry. Then I'm going to look at my graph and say, okay, that is the line. X equals -2. So our directrix is x equals -2. Isn't that easier than trying to remember when to add P or subtract P from which coordinate? Okay. Always do it based on the graph. Okay. Now, I don't want you just drawing a U. Okay. I want you to be able to give me the correct shape for this. And instead of having to plug in numbers, we're going to actually use the geometric property of the parabola. Okay? I am going to come back to this right here. Okay? There is something special about these coordinates. So the coordinates that I chose to plot right here, this coordinate is 1p away from each of these. This coordinate is 2p away from each. This coordinate is 3p away from each. What do you notice about the coordinates that are 2p away? What kind of angle do they make? They make a nice 90-degree angle, and that's easy to count on a grid. right? So what we're going to do is we're going to plot the coordinates that are 2p away from each of the directrix in the focus. So if p is 2, what is double p? 4. So I'm going to take our focus, this is our focus right here, and I'm going to move out double p. So p, p, p. So I moved out 4 from each since p was 2. I don't know, maybe you want to make a note to yourself that that was 2p away from the focus. But what do you notice? How far is this coordinate away from the directrix? 4. How far is this coordinate away from the directrix? 4. Okay, so now we can graph the shape of our parabola. I know this is different. It'll take some getting used to, which is why I want to get through 3 examples. But do you have a question about this example before we move to something that's going to require a little bit more algebra? Okay. Those of you who really like algebra, this chapter is for you. Okay? Some of us are more the algebra people, some of us are more like the trig geometry people. Doesn't matter what you are. Don't say that after every one. There is fractions, but you know what? The standard form for a conic section is actually going to make this example easier than if we were trying to graph it like we did back in Algebra 2. Okay? So if you just trust me here, I know that there's fractions, but we're not scared of fractions. No, not.
Come on, Monique.
Okay? Monique, which direction is this parabola going to open? Okay. We have an x squared in there, and I know it's not in standard form yet, but we at least know since there's x squared and only a linear y, we know this is going to open up or down. And Monique is thinking up since we have a positive coefficient. Okay? We're going to have to get this into standard form, which means we're going to need the x minus h squared, and we're going to need that y minus k. So we're going to do some algebra. Okay? I would first encourage you to subtract over that 5/4 because you know that you are going to need a y minus k. Okay? Then what we're going to have to do in order to force that x minus h squared is we are going to have to complete the square.
Oh, God.
Okay? In order to complete the square, what has to be true about your leading coefficient?
I don't think
It has to be 1. Is our leading coefficient 1? No. What can we do, Max? Well, we'll get there. First, we need to factor out, because you don't want to like multiple. Eventually, that's going to lead to more problems. Let's factor out that 1/4. So we have x squared minus 2x left over. Do you agree?
No.
Thank you. Okay, so now, when we completed the square before, we added and subtracted a number to the same side of the equation. Here, when we're doing conic sections, that's not always going to be efficient. So what I'm going to have us do is we're going to add the same number to both sides. Okay? Does that even out an equation?
Yeah.
Okay. What completes the square here? Let's remember, we take b over 2, and then we square it for our mystery number.
Oh.
What completes the square?
1.
Yeah.
Haha.
Are we really adding the number 1?
No, it's okay.
We're adding 1 times 1/4. And just like that, we have nice numbers, don't we, Max?
Do we do?
Well, what's negative 5/4 plus 1/4?
Oh, it's 1. Oh.
Well, so we have y minus 1 equals 1/4 times x minus 1, the quantity squared.
Whoa.
Okay? However, where do we like our coefficient to be? With the squared or with the non-squared? With the non-squared. Okay, we want that squared to be a loner. It already has the square, it has enough going on. We need the coefficient to be with the non-squared term. He's usually lonely. So we are going to multiply that 4 over. And I'm just going to rewrite it so it's in the form that we usually see it. Okay. You know what? Once you get it into standard form,
Yeah.
I agree.
Easy money.
Okay. So we did some work. Not all of us enjoyed it, but now we just have to identify and plot. So, Guy, where's our vertex? Which one? -1, -1, or 1, 1? Help him out. I'm getting some 1, 1s. All right? We have x minus h and y minus k. So it is going to be the 1, 1. Let's go ahead and slap that in blue. Okay, so there's our vertex. All right. If 4p is the coefficient, and our coefficient is 4, what is our p value? 1. Okay. So when we plot the focus and the directrix, we know that they are going to be 1 unit away from our vertex. Now, we determined that this was going to open up this parabola. Let's review why. The x is squared, so it's going to open up or down. That's what we're used to. Since p is positive, it's going to open up. So I'm going to count p up for my focus, and then I'm going to count down p, and that is going to be where we draw our directrix. So plot them on the graph and then write them down. Make sure that you're writing the directrix as an equation of a line. Okay? We are then going to go double P away from the focus. So if P is 1, we're going to move double P is 2 away from the focus so that we can plot our curve. Now my goal is to get through 3 examples. We may not get to graph our third one, but I want to get through the algebra of it. Are there any questions on this graph or the expectations of this graph before we go forward? I'm not asking you to label these points, but I will see labels for these 3 items off to the side. Okay. All right, we have 6 minutes. Let's at least get through the algebra of this guy. And this is what most of yours are going to look like, this general form. where you have the x squared, the y squared, the x, the y, the constant, and then it equals 0. Okay, so write this down and then turn to your neighbor and tell them the direction in which you think this is going to open.
But then it's right. Well, what do you want to do? That's to the left.
Do you know which desk is his? Next door. It's the middle desk.
To the right.
So if you just go in there, just sit it on his desk. Okay.
Well, I tried to show you.
Okay, so it's going to be hard to tell if P is going to be positive or negative, but we at least know if it's going to open horizontally or vertically. Right, in which one?
Horizontally.
Horizontally because, Addie? Because it's y squared. Okay? So, since we want the y minus k squared, let's keep the y squared plus the 4y together, and we know that we're going to have to complete the square. And then go ahead and move the linear term and the constant term over to the other side so that we can eventually get the x minus k, x minus h, okay? Whatever is squared, keep on one side, and anything else that doesn't go with it, take it to the other side, okay? Riley P., what completes our square? 4?
Yep.
Okay. B over 2 squared is 4. Okay. So what we have is y plus 2, the quantity squared, equals negative 6x plus 6. This is not in standard form because we don't have that 4p times x minus h. So what do we need to do on the right side? Yes, factor out that negative 6, so then we have x minus 1, and we can tell what h is now. This is in standard form. Okay, I kept the squared term on one side, everything that doesn't belong to it on the other side, and we completed the square, and then we had to do just an itty bit of factoring. Okay, now please be careful. Where's the vertex? 1, negative 2, please. X, then y. X, then y. Negative 6 is that coefficient that is 4p. So p ends up being negative 3/2. So now we can officially determine that this is going to open to the left because p is negative and y is squared. I think we're going to get this done, guys. So our focus is going to be 1.5 units from the vertex, but since it's negative, we're going to move inside, which is going to be left. And then we're going to move 3/2 the other direction for our directrix. What is 3/2 times 2? 3/2 times 2 is 3. So if we take p and double it, we're going to move from our focus double p, which is 3. What I will do for you, since we go Monday, Wednesday, Thursday with our notes, and then boom, Friday's our quiz like we normally do. I have a particular way that I'm asking you to graph these. And do you agree that the back of the book isn't always very specific with their points? Okay, not until probably this afternoon, but I will post my graphs for the homework assignment so you can compare exactly how mine look to how yours look. So instead of using Calc Chat, or the back of the book to check your answers, please go onto my website under Chapter 10 and compare your graphs to mine. Okay? Happy Monday!
April Fools.
April Fools. On Happy Monday?
Yeah.
Ugh, Riley.
See you, Miss Elman.
Bye. Have a good one.
Too.